Okay, so you see the headlines all the time, right? These mind-blowing demos, new AI breakthroughs. It's a constant stream. But what does it actually take to make any of that stuff work in the real world? In this explainer, we're going to peel back the layers, look past the hype, and find the hidden architecture that really powers these systems.
Right off the bat, let's get this out of the way. AI feels like magic, for sure, but it is not magic. The real work, the stuff that actually determines if an AI application succeeds or fails, that's all happening behind the curtain. It's pure hardcore engineering. The connectors, the caching, basically all the plumbing that connects a brilliant model to a real-world problem.
So first, let's just acknowledge the highlight reel, the exciting stuff that, we all see and share and talk about. I mean, this is the stuff that's on your feed every single day. A brand new model comes out and just shatters all the old records. A company pushes out a revolutionary update. We see AI doing things that, honestly, we thought were still years away. This is the conversation everyone's having. But it's really only half the story.
So now let's go beyond those headlines. Let's get to the unfiltered truth, because this is where the real challenges are buried.
And this slide, wow, it just lays it out so perfectly. On one side, you've got the public conversation, which is all about bigger, newer, more powerful models. But on the other side, you have the conversation we need to be having, the one that's happening inside engineering teams. It's all about smarter architectures and thoughtful integration. It's a total shift from asking, what can AI do, to how does this AI actually work? And a huge piece of figuring out how it works is getting real about the hidden costs. These are the real-world consequences of deploying AI that you just don't hear about in the press releases. Okay, first up, latency. Think of it as the AI's thinking time. So you ask a chatbot a question, and you have to wait 5, 6, maybe 10 seconds for an answer. Suddenly, the magic is just gone. You might even close the tab. That little delay can make an incredible piece of technology feel totally clunky and unusable. And trying to prevent that, it's a massive engineering headache. Then you've got this thing called data drift. This one is like a silent killer for AI systems. A model can be trained perfectly on a mountain of data, but the world changes, right? Language evolves, new trends pop up, and when that new real-world data doesn't match the old training data anymore, the model's performance just quietly starts to degrade. It starts making little mistakes, then bigger ones, often without anyone even noticing. And this one is absolutely fascinating. Feedback loops. This is what happens when a model's own outputs, let's say AI-generated articles or images, start to flood the internet, and then they become the new data used to train the next generation of models. The AI literally starts learning from itself, which can amplify any errors or biases over and over until it's trapped in its own weird, skewed version of reality. So, how do we solve these huge problems? Well, that brings us right back to our main point here. It's not about finding a more magical AI. It's about smart, deliberate, and often really difficult engineering. This is kind of like the engineer's secret checklist, the big decisions happening behind the scenes. Choosing the architecture, that's like laying the foundation for a skyscraper. Deciding if the model runs on the cloud on a massive GPU or right there on your phone, at the edge, that changes everything. And number 3 is so key. Knowing when the AI should think and generate a totally new answer versus when it should just query and pull a known answer from a database. Sometimes the simplest solution is the best one. And finally, you have to plan for scale, because a system that works great for 1,000 users will just completely snap when 1 million show up. So here's the bottom line. The model itself, the thing everyone's talking about, that's just one piece of a giant puzzle. The hardest challenges aren't in the AI's brain. They're in the messy, complicated plumbing that connects it to our world, with all its real-world data and its messy constraints. And this all leads us to what the future of AI is really about. It's not just some race for more raw power. It's a big shift toward a much more deliberate, thoughtful approach to building these things. This is the new playbook. This is the path forward. We're moving away from just building bigger and bigger models and toward creating better designs. We're shifting away from chasing raw power and toward building smarter architectures. And it's about graduating from AI as a cool experiment to the kind of thoughtful integration that makes it a truly reliable tool for all of us. So I'll leave you with this to chew on. As these models become almost unbelievably intelligent, what's ultimately going to matter more? The raw intelligence of the model itself, or the human wisdom that goes into designing the entire system around it?
because that is the real story happening behind all the headlines. Thanks for digging into it with me.